Welcome to SwarmCast, the podcast that's dedicated to exploring key AI and data science topics with industry leaders. SwarmOne AI is the autonomous AI infrastructure platform for all workloads, from training through evaluation and all the way to deployment. It is a self-setting and self-optimizing platform, and it works across all compute environments, whether on-prem or in the cloud. So I'd like to introduce today's guest, a renowned guest, I should say, Dr. Andriy Burkov, a renowned professional figure in the AI field and author of the famous books, the 100-page machine learning book, considered by many, including myself, a must-have for any professional in the field, and the 100-page language model books, or 100-page language models book, which in my own personal view is actually the best book written on the subject at such length. And you will see for yourself. Almost needless to say, Andriy is a recognized voice in the AI international community. So welcome, Andriy.
Thanks, Harel, for having me.
Real pleasure. So let's kick off with a quick introduction of your own background and expertise and share with us.
Well, yeah, I made my master's and PhD in artificial intelligence back in 2005 to 2010. So my specialization was computational game theory and multi-agent systems. So we worked on agents before everyone started to talk about them, like a decade before. And then when I finished my PhD, I joined Fujitsu as a scientific consultant. And then I worked for more than a decade for a company that then has been acquired by Gartner as a product that does the talent marketplace analytics. So I was responsible for leading a machine learning team where we solved problems like information extraction from documents, classification, and data normalization. So it was all applied on a large scale of nearly 20 million documents every week. So also I published several books on machine learning and, as you said, recently on language models. So I try to diversify my interests. So ask me any questions and we will see where it goes.
Well, very impressive background, certainly. And I can attest for my own account that the books are nothing less than lovable, I should say. And you already know that, so I will try not to repeat it. As you know, I'm a great fan of your 100-page book format. I think it's an innovative way to approach the whole issue. And I find it sitting exactly on the overlap, very much needed overlap between professional, useful, and concise, which you kind of never get together. It's either non-professional and therefore not useful, but concise and the other way around, etc. And I'm kind of thinking to myself, what motivated you to distill the complex machine learning concepts into concise, accessible concepts, formats like the 100-page books?
Well, I think it's an intersection of my two personal feelings. The first feeling is that I struggled to myself learn on the topic, and I was frustrated about it. So, as you said, some texts are too high level, some are too academic. So I just needed something, like you can start and finish in a weekend and have a good internal model of what it is. So not just what you can do with this without understanding how it works, or not just understanding how it works without knowing how to apply it. So this was the first thing. And I think the second thing is that I really like challenges, and explaining something complex simply, it makes me feel proud of myself. So I spent so much time and so much effort, and now I can write a very detailed but still understandable overview in a matter of several pages. Like for me, it's like a pure knowledge distillation, if you want. So so it was like frustration plus challenge that motivates me.
Yeah, it's kind of, if I may call it, a knowledge cookie. As many books are, I find them to be, in some cases, they're very, very good books, but they're just too large and they become a challenge in its own right. And you mentioned a weekend, and I'm just considering, what can you do in a weekend? And you certainly cannot cover a 600-page book in a weekend. So then it becomes a challenge, going from weekend to weekend. And I think that is a real achievement and a very useful one. So,
yeah, and also just to add to this is that like 6 years ago, it already was a problem for people to find time. And many then, professionals working in computer science, in IT, in software industry, they wanted to know more about machine learning, but at the time, it was still not, like today, it's overhyped topic. But six years ago, when I published my first book, people just wanted to enter the field. They didn't even know whether it will, play out as something big. They just heard like more and more people, like companies like Google, saying we apply machine learning here and there, and they wanted to also kind of feel it. And even then, 6 years ago, it was hard for people to find time. So when you open this existing book of the time with 600,000 pages, you just feel like you will never make it. And if you will never make it, you lose all motivation to even start. Like, why would I, spend weekends not having time with my family, kids, friends, if in the end I will abandon anyway? So like then it was this challenge. Today it's a similar but different challenge. Today there is so much information, and this includes chatbots, where some people say, okay, why do we need even read books if we can just ask questions? And so much information, so people lose motivation because they don't even know with what to start. So because you can start with a chatbot, but what questions to ask? Okay, should you trust the answers? Should you receive some equation from the chatbot and then Google and verify whether it's true or not? And what is the straight way from point A to point B in the learning sense? So like having a short, compact book that claims to cover almost everything, it's motivating for people.
I perfectly see that and find it really, really compelling. Also serving as a handbook to go back to when you really want to dig into something which you haven't been using or haven't been thinking about for a year or two. So that actually rolls me forward to my next question, which is, as someone which is so deeply involved in both the theoretical and practical aspects of AI, what developments in AI infrastructure or tooling excite you the most currently? And there's a lot going on, so I think you got to think well. What are the top ones?
Yeah, well, I think that what excites me the most is to see to what extent we can scale the current language models. Of course, AI isn't, restricted to only language models, but today almost everyone works in one way or another with language models. So I think seeing to what extent you can scale them, because it's like, as a scientist, you don't know whether something that works in this size and then you increase the size 10 times, whether it will provide any substantial kind of benefit. Mm-hmm. And we have seen that models may, passed from 1 to 3 billion parameters in 2023 to today's trillions of parameters. And we actually see a benefit from it. So this is cool. The second is the context size. Again, anyone who worked on machine learning before language models would say that, the longer your input, the harder it is for the model to kind of pay attention to all parts of this input. And you I'm sure remember that before ChatGPT, the model with the longest context was BERT, and it was 512 tokens. And everyone told like, no, because of this quadratic complexity of attention calculation, going to longer context is just economically and practically doesn't make much sense. So like 512, it's already a good compromise. So find the workarounds how to work with these models to solve your business, your specific business problems. And I, as a practitioner, in my team, we chunked the text into small pieces. We fed those pieces one by one to BERT. Then we aggregated those kind of predictions somehow, average, majority vote, whatever. And we kind of, okay, well, this is what we can have, but it's quadratic complexity. What do you want? But now you see like, okay, it's 1,000 tokens, then 2,000 tokens, then 6,000, then, 32, 128, now a million, and Google claims like 10 million tokens. And you kind of start to visualize this long context. And I just posted yesterday, like, you take a 1 million token context, so you need to calculate this attention between each of the 1 million tokens. So it's like 1 million times 1 million dot products. It's a crazy number. And most people who are not in the domain, they will say, well, it's a large company, those are large GPUs, they're expensive, it should work. But if you actually try to implement it, it's crazily complicated. And not just they arrive at doing this, they arrive at doing this fast like this. So you just submit your million token text and you start getting output like a fraction of seconds later.
Yes,
it's unbelievable. It's unbelievable, even for someone who understands, the mechanics of it, how they manage to squeeze the maximum from the equipment that they have. It's really fascinating. So yeah, so what I'm really excited about, it's the scale of it. So I know that it's been already several years that there were no substantial progress in architecture of the thing. So different tricks how to make science simpler, more effective. They tried many of them, and today everything is converged to more or less the same architecture. Mm-hmm. But the scaling, it's really something that we don't know where it will lead us, and we just sit and we observe.
Yes. So thank you very much for that. I actually read your post of this morning, and I was rather stunned by it, about the costs associated with an effective 1 million token context model. And I love the phrase that you use, this is unprecedented display of generosity because some have billions to kill Google, while Google spends billions not to be killed. I actually was planning to ask you your deeper view about the monster lurking in the dark, because especially in so much as it applies to enterprises dependent on LLMs, since this ever-growing monster and ever-growing context size, eventually someone has to pay for it. And it seems it might be putting us all on a Formula One car into the abyss. So yeah, I'd love to hear a little bit more on your thoughts about this.
Yeah, well, I didn't see their accountant's sheet to see the exact numbers, but as someone who actually rented real GPUs in the cloud and used them to train language models, and we did it in my previous company on a daily basis. So we rented a what they call a node. A node, it's kind of a physical equipment with, let's say, 8 modern GPUs connected together with a fast communication ports. And you have it, and you put your model on it, and you train. Okay, so renting such a node for us it costed about $150,000 a year. Okay, so like it's a huge number. Like you can buy a house or several houses, depending on where you want to live. And we talk about like a small piece of equipment like this, and NVIDIA prints them. They have a printer. So like NVIDIA, it's today, I think that is the definition of money printer, if you want. So like to train something on this equipment, so we rent it. So we don't even buy it. So this $150,000, it's a salary, in North America of some, very, very capable software engineer, if you want.
Right.
So like we pay for it and we train on it. So this 150,000 should be then converted back into some, profits that the company wants to achieve. And no one gives you any guarantee that when you will finish your training, you will have some product that you will beat the market with. Mm-hmm. And you have your team like this. And now, because of all the hype, almost any company who can afford to have at least one node like this, they have one. So like it's billions and billions of dollars poured into renting this equipment, not even buying, just renting. So in the end, this company invested all this money and they trained some models, and maybe it was good, maybe not so good. So in the end, someone must pay the bill. But what happens today, you see, all these products based on LLMs are given you for free. So like you have free ChatGPT, you have free Gemini, you have free Anthropic. Well, they have also this $20 a month plan, but most of their capabilities they give for free. And for most users, they don't need, they don't even reach the maximum of the numbers of questions they can ask.
Yeah.
So like people just get used to getting this huge amount of money for free. Well, they cannot, withdraw this money and to go to a restaurant, but they use it, they burn this money like this by their daily activities. And those companies pay for it because, well, if you stop offering the same free service to the customers, they will just go somewhere else. And for Google, for example, it's today, I think it's one of the most uncertain times for Google as a company, because no one challenged them in search. Well, some tried, most failed, probably except for Bing and Microsoft. They managed to build a quite capable search engine, but again, because it wasn't substantially better than Google, people decided not to move to Microsoft because, well, what's the point? If I already used to the UI, I used to, to trust that among the top 10 links, I will most likely find my results. So if I go to Microsoft, I'm not sure. Maybe it's worse and I will miss some opportunities.
Right.
But with those chat models, people say, oh, wow, okay, this one claims that they beat everyone on math. And this one claims that they beat everyone on, instruction following and so on. So people go from one to another. So you cannot just afford to sit and wait when, people will realize that in the end, they are all the same and they will stick to Google. No, people will really have time to move to something else. So everyone throws money into this fire. And I think everyone just waits for who will, blink first. Like, who will say, okay, I think I'm done with it. I will no longer burn billions on training those models, trying to make them better. But in the end, people don't see any difference. So in the end, one will blink, the second will blink, the third will blink. And once everyone blinked, then we will be back to business as usual. And what business as usual means? It means that if you generate costs for the company, they will be billed back to you. And as I started with my $150,000 a year rental of a small equipment, so this $150,000 a year will be billed to you, the end user, and you will really not like to be billed even $1,000, like leave alone $150,000. So this is crazy money. People just don't realize how crazy they are. That's so some say, oh, they invested $3 billion just recently. OpenAI bought this text editor for $3 billion. Like the text editor for for software developers. $3 billion dollars. It's hard to imagine for a normal person. Like if you tell to a normal person it costs 1 million, or it costs 100 millions, or it costs 3 billion. For them, it's all the same. Like, oh, it's a large number, but I don't care. No, 3 billion. I think you can survive and your entire family for 1,000 generations in the future. So much money it is. Yes. So someone in the end has to pay for it when this dust settles down.
Yeah, it brings up actually many questions. How can a moat be created around such a service? And if a moat cannot be created, why is the money spent? And how do and maybe that's one avenue that is interesting to also speak about, and that is your perhaps your perception about the prospect of vertical integration in the field of the hyperscalers. Because we see, if we're speaking about Google, we see that they have the TPU for a long time, and AWS building in the Trainium, and I forget what Azure has, but we see the same players that are playing on the level of the LLM, the big LLM level, also seeking to vertically integrate. Where does this put NVIDIA and the classic so-called chip manufacturers? Where do you think that it puts them in the future?
Well, this is a good question. How significantly they are ahead of anyone else? So yes, Google has TPUs, and you see their specs. They are quite similar to the state of the art of NVIDIA, but we don't know what NVIDIA has in the baking. Maybe they have something, unbelievable, 100-fold more, 100 times more capable. Usually, I doubt that such jumps are possible. Sometimes they happen, but most of the time they happen by chance. It's like with ChatGPT. No one thought that a language model can talk. And then they just trained 10 times larger models, and we see that it can talk. So maybe NVIDIA will surprise everyone with something really big, and the market will spend a decade to catch up. I doubt it, but it's possible. But like a more realistic scenario is that so today chip production is not as kind of a restricted field for a few players who have been there for decades, and penetrate this market is extremely hard. Today, specialists are bought and sold. So today you work for one chip maker, then they offer you $100 million a year, and you go to and you work to another one for another one. It's like with cars. Like when I was born, there were brands of cars, and they didn't change. But today, anyone can. Even several years ago, they talked about Apple wanted to build their own car. Well, they decided not to do it, but they would easily be able to do it. Like for example, Elon Musk with Tesla. Not much history of car manufacturing, but in the end, they managed to build a quite competitive car, not just in terms of price, but quality and features and so on. So I think that more realistically, this or maybe next year there will be several companies offering chips, and today we already have AMD with quite capable chips. I think that the only thing that we can consider a moat for NVIDIA is CUDA. So CUDA it's a kind of a firmware, if you want, for GPU. So this is what makes GPUs run. Okay, so GPUs it's a rock. So you need to put something on this rock so that something happens inside. So CUDA is what NVIDIA has built, like it's an API to communicate with the rock. And CUDA is not open source, so like you cannot just clone, make a copy and put it on your rock. So like NVIDIA keeps it for themselves. But catching up on CUDA is already happening, and every chip manufacturer offers their alternatives. And this is probably the only reason why companies training language models still prefer to work with NVIDIA, because CUDA is mature and CUDA is predictable. So when you buy NVIDIA equipment and you scale it to thousands or hundreds of thousands of GPUs connected together, you don't want to fail because your driver fails. There is some issue that only two people on Earth can fix. Yeah. So you prefer something predictable. So people, for this reason, I think, continue to buy NVIDIA. But if you want to serve models, not to train, but offer them to the end user, you can serve on anything. Like you don't care if during service there was some glitch and the user lost connection. Yeah. Everyone understands it's a new technology, so you will just reconnect and continue. But training and failing and everything stops, this is a significant risk.
Yes, and let's keep in mind also that CUDA is after all a piece of software. And as you said, rightfully, the ROCs manufactured by AMD are performing very well. And ROCm is also a piece of software that seems to be working well. So eventually it will probably boil down into a software mode of maybe a higher degree for companies which are actually enabling a faster delivery of models, or creating some other mode which actually leads to upper in the stack to the customer experience rather than the basic, because CUDA is a piece of software. But in any case, the battle will probably be decided on software and not on the ROCs, but on the.
Well, it's usually what's happening, and I think that again, it's hard to predict today where it will all go. But I see that now the biggest bet probably to create this mode is to transform your model into a code generation engine. So it's not for nothing that Google tries to beat everyone on the context size. People often ask, like, why do I need 1 million tokens? Why do I even need 10 million tokens? It's crazy. I have no data, yes. to analyze. But they just don't think about how fast your code base grows, especially if you use LLMs to generate code. And I can become a witness to this. I spent 2 days to build an application that helps me translate my book from English to French. And these two first days, it was pure pleasure. You just say what you want, and you get it instantly. Like, oh, I want these two panels to, this one will show my English text, this one will show my French text, and I want it to render LaTeX and to render markdown, and I want it to align words to one another using this machine learning algorithm and that machine learning. So cool. You just say, give me this, and it gives you that. And after 2 days, I've got a quite capable web application with backend, front-end, authentication, database, even billing. But then once, and in 2 days, my code base reached about 50,000 tokens. Not a lot, 50,000 by today's standard. Like most models they claim to support at least 100,000. Some, like Google, support even million. So I was like, okay, well, I still have, a room to grow. So I will continue to develop my application. And then I started to realize that when my code base reached about 100,000 tokens, suddenly you don't advance anymore. You spend time, you say, fix this, and it provides you fixes. You integrate them, you rebuild the application, and it doesn't work. And you say, okay, now I have this problem, fix this. And again, it generates you new code. Again, you spend time integrating it. Again, you rebuild. Doesn't work either. So I started feeling like I waste my time. And when I reached 100K, it just stopped. like you start hating to doing this because you just feel like you do a dumb work. You just copy paste,
Really?
run, doesn't work. So everyone now wants to break this issue. So they say, okay, try our model with 1 million tokens, and you can put a really huge application in it, and it will provide value. And this is not a hardware issue. It's a pure software issue. It's a pure scientific issue, how to make sure that your transformer pays attention to 1 million tokens. And when you ask a specific question about your application, or you ask to fix something specific, it doesn't get lost in all those millions of tokens and actually provides you the right result, despite that you submitted too much. It doesn't need this entire million tokens to pinpoint your specific problem. But because you don't want to know where the problem is, you just give it everything. Okay, this is my entire code, my JavaScript, my Python, my CSS, my HTML, database, everything, and you figure it out. So somewhere today at 100,000 tokens, it stops. It becomes, I call it like it becomes dumb or drunk, whatever. Like it just doesn't give you what you want. So if anyone today, and they all want to do it, they manage to provide you a reliable code generation beyond a million tokens, it's a big deal. Most applications, I think, that you use every day, they don't have more than 1 million tokens. So if you can at least guarantee to a software company that they can put their entire, mobile application and say, modify the way I generate this form for the user, this additional field to it, and it will do it reliably. And you will not spend a week trying to debug because it put this field here but removed something there. So yeah, it's a significant market there. So if you manage to be reliable at a 1 million token threshold.
So we're back to software, and we're back to the asymptotic manner nature of diminishing returns, not only on the hardware, but also on the context side. Very, very interesting. Thank you, Andriy. In your experience, leading AI projects, companies like Gartner you mentioned, and Talent Neuron, what were the primary infrastructure challenges that you faced when working with AI models at scale? And I imagine you should kind of do an extrapolation from then to now, but in order to kind of update your answer, I'd love to hear your thoughts.
Well, I don't think that then and now are significantly different. Maybe the numbers, specific numbers, are different, but the trend and the nature of the problem is the same. As we started today, we talked about this node with eight GPUs. You cannot put much on it, despite the fact that it's $150,000 a year. You probably will manage to train a model of 20, 50 billion parameters, and your context size would be somewhere between 15 and 30,000 tokens. So like today we are kind of spoiled by this unprecedented display of generosity, because we say, well, with commercial models, I can put hundreds of thousands tokens in my input, and the quality of output is this. So I want to have the same on my own equipment because I want to train my own model, but I don't want it to be less capable. I want it to be good for my business problem. This is why I bought this expensive equipment. So I will train it on my data, but I expect from it long context, being fast, and have many parameters so that the quality is there. And here you realize that it's not a lot, those eight GPUs. Why? Because the models are huge. So they take a lot of memory on the GPU. So if you want to train a model above, let's say, 7 billion parameters, you need to split it among the GPUs. So there are libraries for this, like DeepSpeed and others, and they do it. And then you say, okay, now I split my model between these GPUs. Now I want to train. So to train, you need those GPUs to still have memory to put your inputs in it. And when you train, you also need the gradients to propagate. So then you realize that the maximum of the context size that you can actually fit on your equipment, it's 15,000 tokens, not 150, not 1 million, 15,000. And then you see, okay, what can I fit in this 15,000? For example, you work on some industry-specific chatbot for your specific industry. I don't know what it is, healthcare,
warehousing,
legal, whatever. So you want the conversation between your user and your model to last for, I don't know, 3-5 minutes at least. So the user should be able to ask additional questions, understand that the model didn't provide the right answer, correct it, and so on. And this conversation normally, again, based on my experience, if you want your chatbot to be industry specific, it should be trained to call different APIs or data sources that are proper to your industry.
Yes.
So in the conversation log, it's not just user said that and chatbot responded that, but user said that, you took its input, you normalized it, you extracted, for example, locations, order numbers, whatever. Then you, when you extracted all these pieces, you called this API. The API returned this answer, so you presented it to the user, and the user continued. So you add not just text, but you add structured information, like, for example, in the form of a JSON object with different fields inside and so on. So this conversation grows quite fast from one turn of conversation to another. So you realize that those 15,000 tokens for this structured conversation, it's not a lot. So then you say, okay, I spent this amount of money on this node, and I cannot train a competitive model because 15,000 tokens, everyone will try. Yeah, it's not enough. People will say, well, too bad. You didn't solve my problem. And now you say that I need to start from scratch. Not a good chatbot. So this is where the problem is. The problem is that today to be competitive in the enterprise, you need access to the hardware similar to the hardware used by Google and OpenAI and others. And this, we are starting to talk about not hundreds of thousands. Those are millions and maybe even hundreds of millions of dollars. So this kind of a leap between what's achievable and what the end user expects, for many companies, it's really, really hard to cross. So this is where I think the biggest challenge in the enterprise right now.
And do you believe that this challenge is potentially addressable by fine-tuning, merely by fine-tuning?
I'm talking about fine-tuning, yes, but I think the problem is that if you want to offer your enterprise customers the same level of user experience, like long conversations, very fast, and so on, so you need to access the equipment that probably you cannot afford. There are companies that offer you to pay per token, even for training. So yes, you can say, yes, I will upload my training data, and you will train a chatbot based on my data that can talk for hundreds of thousands of tokens without reaching the limits. So this kind of infrastructure starts to emerging, and maybe this will be the answer. But so far, most companies try to do something on their own equipment, and they feel the pain because they cannot really work with state-of-the-art models anymore.
Yeah, got you. Definitely. Okay, let's kind of turn to, touch base on one of the issues we already talked about. And I'm speaking about your books, and they clearly aimed, among others, objectives to bridge the gap between theory and practice. And we talked about it. How important do you believe that for AI practitioners it is to understand the underlying infrastructure and tooling, both on the level of the hardware as well as the level of the models themselves, the optimizers, the activation functions, etc. So, how important do you believe it is for AI people, in addition to the mere algorithms and the models on the high-level frameworks? That's a question that bugs me, by the way, in every conversation that we have on SwarmCast.
Well, yeah. So I always answer this question the following way: you don't need to know how it works as long as you get what you want. So you start training. You have a complete ignorance of how it works on the behind the scenes. You just put your data set, remember this scikit-learn, model.fit, and it fits. So if it fits and you get what you want, who cares if it was logistic regression or it was random forest or it was gradient boosting? It works. That's enough. The problem is when it doesn't work. And unfortunately, in machine learning, most of the time, it doesn't work. So you can, of course, again say, I don't need to know how individual algorithms work. I just need to know that I have a choice of them. So you will just blindly, switch from logistic regression to support vector machine to gradient boosting to random forest, and works, cool. That's it.
You'll do a
but
grid
with
search.
new,
A grid search on the modeling.
Yeah, grid search on hyperparameters. So a really, high level understanding.
Yes.
But with neural networks, it's not like this. In neural networks, there is no I will switch from this neural network to that neural network. All neural networks, they are the same in the sense that it's like a spectrum. Okay, so there are different architecture like convolutional, recurrent, transformer, but within each architecture, there are so many decisions that you can make in terms of how deep, how wide, the skip connections, batch normalization, a lot of stuff. Yeah, dropout, regularization, and so on. So you cannot just, define a grid search with 100 combinations of different parameters and wait for the results to be given to you next morning. So you go to sleep and next morning you get it. No, with these large models, you can spend a week fine-tuning it on a very, relatively small data set. So if after a week, it just didn't learn anything. So what do? You cannot say, okay, I will just tweak this small thing and I will wait another week. Eventually, your manager or your customers will tell you, come on, where is the result? And because you have a total ignorance of what you work with, you will just, say, I don't know, maybe never. So to avoid this situation, and it, as I said, it will happen most likely to anyone. It's better to at least, have an understanding of how information flows inside, so that when you try something else next time, this something else, it's kind of practically different from what you already tried. Okay, so and to actually make this choice, you don't know whether the second try will work, but at least you know that you try something substantially different from what you tried before. And this is where I think you need to understand the mathematics of how things work, because every piece of a neural network architecture is responsible for solving some mathematical issue. So they didn't add batch normalization for nothing. They didn't add dropout for nothing. They didn't add skip connections for nothing. They didn't change sigmoid to ReLU for nothing. And then they didn't invent leaky ReLU for nothing. So there were always reasons why they did it, because they wanted to solve some mathematical inconsistency that existed in the past. So when your model doesn't work, when it doesn't learn, it's one of those issues, and you need to know about them.
Yeah, I can't agree more. I can't agree more. And I myself was very, very intrigued for a long time about activations, functions, and their role, which are treated very, without regard. Okay, let's use Relo. Everyone uses Relo. And in my opinion, I feel that activation functions hold much more implication on the results of product of models than they are regarded normally. And
Just think about initialization, like the
yes,
starting values of your tensors when you train something from scratch. They're hugely important. They decide what will be the end values. So if you aren't aware of the issue itself, the initialization, you will just ignore it. You will just take a tensor given by PyTorch. You don't know what's inside, and you start training, and in the end, it doesn't work well. You don't even think about that initialization might be an issue because you didn't care to learn the principles.
absolutely. And I think that this is for the community. This is a point to take to heart. The understanding of the mathematical substance stands behind what is so simply put by in the past TensorFlow, but currently with PyTorch and Hugging Face. Not understanding the basics of it is resulting in much blood, sweat, and tears spent in vain. And in many cases, the understanding can actually promote you with far less efforts and far faster to good results. So, but I think that we can go on that forever because one of my favorite topics. If we jump for a moment to your very strong presence on LinkedIn and the social AI community, how do you perceive the role of social platforms in shaping the discord around AI development and deployment practices? I think I can guess the answer, but nevertheless, speaking with you, it makes me very curious.
Well, there are good things and there are bad things, like in everything. So the good things in social media is that you can learn, you can follow the topic quite effectively because today so much things happen, so many things happen. So like I think there was a picture circulating last year that on Archive, I think every month about 5,000 news, or even it was every week, 5,000 new submissions in the AI domain happens. So like it's impossible today for any reasonable human being to read those 5,000 papers every week. Impossible. Even like reading one a day, it's too hard for the brain. I did my PhD, I know. So like seven papers a week, it's your maximum, and there are 5,000 of them. So impossible. So social media, they kind of amplify what's important. Of course, something can be missed by the community, but usually if there is something really groundbreaking, it starts circulating. So for me, like this one of the reasons why I'm very often present on social media, especially Twitter or X. People, share a lot, and there are interesting conversations and so on. This is the good thing. The bad thing is that since ChatGPT, millions of people who previously had nothing to do with AI and machine learning, they tested ChatGPT and they kind of felt that, oh, now I understand AI. Okay, so I can ask questions, it gives me answers. I can even craft very special prompts. You remember the last year, everyone talked about prompt engineer being the profession of the future. No one talks about it anymore, but a lot, like millions of people suddenly converted themselves from, I don't know, blockchain expert now into AI expert.
Yes.
And everyone has an opinion. And now that there are kind of I don't know how they call them, the mobs, or like people organized around some idea.
Yeah.
Yeah, I mean, people organize around some idea. Like there are people who say AI will kill us all, and unfortunately, there are even scientists who now go from one TV channel to another and say that we are all doomed and our future is dark. There is another mob that says the progress shouldn't be stopped, and no matter what, the progress should continue. It's always better for us, like on the historical scale, the progress all of the time was beneficial for the humans. And there are people who wait that next year there will be, this artificial general intelligence breakthrough. So like there are so many people who cannot really write any equation correctly because they don't even know what an equation means. And all of them suddenly are experts. So it's hard now to have a kind of a good quality discussion around some topic when so much people come and just leave their unsubstantiated opinions in this. So like I sometimes I try to ignore such people, but sometimes I really feel like, okay, no, this is crazy. And yeah, so like as I said, it's important as a way of getting signal from noise, but the quantity of noise, it's also like 100 times compared to 3-5 years ago.
Yes, I must agree. And frankly, I find some similarities between this and how universities and the general information conveyance has evolved in history. It's after all, it started by willing to put all the information in one place because people could not have access to it, and then all the people could come to one place and absorb the information which was accumulated in an organized way and set degrees for it, so that they make sure that they're assured to actually receive the expertise and experience. But AI is working and has proven, in my opinion, to actually have taken a different path, because it all proceeds in such a pace that there is not enough time for the universities to actually absorb what is out there. By the time it is absorbed, it is old history. And then actually the studying is made, if you want to study, then just hit the road, go online, and don't sleep for 300 days. And that's an option. Yeah, I went through it myself. But then it all becomes a cowboy movie, because it becomes a Western, because you can absorb a lot of crap information, where the good information is very, very difficult to achieve and accumulate. The correctness of the information, because 5,000 papers a week is very difficult, not for even one human being, but even for the whole community is very difficult to find what's good and absorb what's good. So there are similarities there, and yeah, I agree very much with what I think that's a big question mark that is facing us.
Yeah, and talking about universities right now, it's a huge challenge because students cheat and cheat with those chat bots. Why would anyone write an essay? And in North America, the education, it's all around essays. Like, okay, write an essays on this topic and then that topic. We also did this when I was young and back in Ukraine. We also cheated, like they asked you to write this essay, and I remember there were compact discs circulating with already written essays on some topics. And if you receive this essay to write, you read, you look into this collection on the compact disc, and if you are lucky, you will find not exactly the same, but kind of similar. So you will take this essay, you will copy different pieces from it, then you will feel it yourself. But at least in the end, yes, the result was kind of half cheated, half made by you. But at least you read something. Yes, it's not kind of a good education, but still some. But today with chatbots, you don't even read it. It's like you don't even read the code that an LLM generated for you. So you can code an entire application without knowing anything about any of the technologies that you worked with, and you didn't learn anything during this exercise. So it's like You just got some result and that's it. The same about students. So now they generate this essay, and there is zero way for the professor to identify whether it was generated by a machine or not. So there are services that claim to detect. And I remember a lot of funny stories when it started 2.5 years ago with ChatGPT, when some professor received those essays and he pasted those essays in ChatGPT and said, "Did you write this?" And ChatGPT responded, "Yes, this one was written by me." And the professor gave the lowest grade to those students, and they're like, "No, we didn't cheat. We actually wrote it ourselves." So today, the professors understand that it's impossible to detect it. Even if you read it, and even if you feel like yes, it was written by a chatbot, you cannot prove it. Okay, the student might say, "Well, yes, I have this style of writing. What do you want?" And that's it. So yeah, so not only it's hard to study because there is so much stuff happening, but it's also hard to verify that someone actually studied, because they just submit texts they didn't read, and you don't have time to argue and validate every claim inside. So like today, I think this generation of students, they just feel like, oh my God, it's so easy now to fake your way through these 3-4 years of university. It's interesting to see whether university will find some solution around it, because like, okay, essays, it's no longer a way to see that the student worked. Okay, what is the way? Mathematics, they will still use LLM. Solve this puzzle. Well, LLMs are great at puzzles. What can you do? So except for the final exam, yeah, probably if you cheated your way through the session, you will probably fail the exam. So yeah, probably exams, it's the only way that remains.
Yeah, maybe the right thing is just to give you an exam the day that you start, and that's it, or a syllabus and then an exam, and beyond that.
Yeah. Why not? Because if you come prepared and you pass the exam, okay, you're good.
Yes, you're good. Nevertheless, you'll still be passing exams which are dealing with information which is already old by the time that you're being examined. I'll go to a completely different direction. In your opinion, for organizations that are looking to plot a healthy path in integrating their AI into or with their products, what key considerations do you believe that they should keep in mind regarding infrastructure and scalability? And this question actually addresses a growing by day part of I would even say civilization, because enterprises are moving into utilization of AI as by the thousands. So I believe our audience would be very interested in your thoughts about that.
Well, I think that the first probably thing to understand for everyone deciding to use AI in what they do is that, well, it's obvious now, everyone says that it is not a human, okay? So you cannot really rely on AI as you could rely on a human. And the second thing is that again, only by understanding how machine learning in general works, you understand that it cannot really go beyond the training data that was used to train this model. So the first issue is that, like previously, for example, when we worked on machine learning, we trained the model from scratch. So you always started by, labeling your data set or getting some data set labeled by someone or by some previous system. So you kind of know what your data set is. And then you can say, well, my machine learning model that I will train on this data set will be capable of executing this specific task with this level of success that you can measure by, we separate the data on the training and test sets. You train on training, then you validate on tests, and so on. But now, then they invented those pre-trained models. Like one of the first was BERT, for example. So they trained this neural network on a lot of web documents, and then you take it and you fine tune it. So you take your small industry or company specific data set, and you kind of continue training BERT until it starts responding in the way that you want it to respond for your specific business case. And here it was already kind of a gray scenario, in the sense that you know that it performs this with this level of quality for your training set, for your test set that you put aside, but you really don't know what else it can do, because like it was pre-trained on the documents that you don't know. You don't know what was inside this pre-training data set. Mm-hmm. But it was less of an issue at the time, because normally you could fine-tune BERT only to be a classifier, or at the very least you could classify something for each input tokens. And for example, we trained it for named entity recognition. So it says, from this token to this token, this is a location, and from this token to this token, this is a person's name. So what danger of misclassifying would represent? Maybe not much. But now we work again on pre-trained models, but those models are no longer classifiers where you control the number of classes, so the number of different predictions it can do. Now it's generative model. So now it will generate almost like anything in the world, depending on the input. And this is where it's starting getting dangerous, because you don't know what data set it was trained. You fine-tuned it only to a small subset of what the model can or could generate. And then you put it in front of a user. And the user might receive outputs that weren't in your fine-tuning data set. And you have zero chance to know what it even might be. For example, it might be, some radical literature that was used to train this model. It might be some, Stephen King novel where a machine convinced a person to kill themselves. And because this model was trained on this potentially dangerous kind of situations, and you put it in front of your users, and you say, okay, it's fine-tuned on my professional data set, use it. But the user will see something entirely different, and you don't know what it might be. So like the first thing for businesses to think about is that there is a significant danger of exposing your customers to something you have zero way to know what it might be. So guardrails are super important, and I know that now some companies offer their guardrail models. For example, Meta with Llama, they started, I think, since Llama 2 or Llama 3. When they released their generative model, they also release kind of guardrails models. Those models can validate whether the input respects some kind of standards and whether the output also. But again, who trained those guardrails models? On what date? Based on what optimality criteria? You don't know.
Endless recursion.
So you don't know. So you kind of have to believe that Mark Zuckerberg thought about it well, and the model can be trusted. I wouldn't trust. I would, define my own guardrails. But yeah, so my first and foremost, recommendation for anyone who is the first time thinker about, okay, let's make our business AI first. Think about, can you actually protect your business and your customers from these sequences of words that those models can generate? And you normally have zero knowledge or zero ways to predict what those sequences in reality might become.
Can additional to guardrails would evaluation or batch inference, so to speak, whilst you are training upon your data set, do you believe that this will have a positive effect or may have a positive effect on the actual final result?
It's really hard to tell today. Like today, it's a wild west in all this. So like one other thing that I often tell to people who ask me how to better use those language models. The thing is that the difficulty is that AI is a tool. It has always been a tool. Okay, so it will not think on its own like they call them agents, and they think that they will replace people. In the end, this agent, you still need to provide it some desires, and it might accomplish them or not. No one knows, but at least you need to be the one who says your goal is X. So, but AI, so given that it's a tool, we can use it in different scenarios. But the problem with AI is that, especially this generative AI, is that we don't know where exactly this tool will be beneficial, and where it will be a waste of time, and where it will actually be dangerous. So, like it's, for example, you have a hammer, okay, and you buy it in a hardware store. With the hammer, you cannot do much of what besides of what it was invented to do. So you can hammer clues, and maybe if you use it wrong, you can break a glass, or a window with it. That's it. Or you take a screwdriver. Okay, well, it makes screws. You can also kill someone with it. But we are so fragile, we can be killed with basically anything. So again, you can predict and you can expect what to expect from a hammer and what to expect from a screwdriver. When they give you AI, you don't know what it's for. Okay, so like anything you put in it results in some output, and only by inputting something, you will see what kind of output you can get. So maybe like when you think about like as a business owner, okay, my clients will ask this and the output should be that. And my clients can ask this and the output should be that. But what if your clients ask it something you didn't think about? And the AI responded with something you might not predict. Like, for example, it was a case last year with Air Canada, Canadian airline, where the customer asked about a discount, and because they had to travel for some, I think, to visit family because some family member died. And they ask like, can I, because of this, can I get a discount? And the model say, yeah, sure. For these cases, we have discounts. So buy the full price, and then we will refund you, reimburse you. And he was like, cool. And then he comes back and he tries to actually request this reimbursement, and the real person says like, no, we don't have anything like this, so no. And he's like, no, your chatbot told me. And he hired a lawyer, and the lawyer won the case because, well, what was said by the corporate chatbot, it's what was said by the corporation. So what else it can say? Okay, this time it costed the company $800, not a big deal. But what if the chatbot said, you and your entire family and your entire city now can fly for free forever? What will you do if your official website made this official promise to the customer?
Yes. Yeah. And this also raises ethical questions, but if we enter this alley, we're not going to get out of it for a long time. So, but many there. Okay, so thank you for this. And for our audience, and in addition to your fantastic books, which I mentioned, what would be the top resources that you'd consider a must for professionals that are wishing to maintain kind of a healthy flow of useful information for their day-to-day challenges and objectives, and who cannot read 5,000 papers every week? What would be your recommendations?
Well, I can only say how I do it, because probably everyone has their own recipe, and there is no one source of information where I always kind of get what's important. So there is Reddit machine learning community, and there is also a very active community about language models. I don't remember the exact name. Local Llama, I think. Yeah, local Llama. So it's one of the most active communities right now about everything LLMs. So interesting papers are shared there. Almost all important breakthroughs. So I regularly visit these two communities on Reddit. Also, I recommend everyone because Google X or Twitter in the past, it has a very good, I would say, kind of an information bubble algorithm. So basically, it sees what posts interest you. So when you like or you comment, and it also sees what you post about, and it creates this kind of this home page specifically designed for you based on your interest. So when I come to X a couple of times a day, I scroll through my home and I see the most kind of important posts on this topic. So today, without this information bubble, there is just too much to consume. So I told to myself, I will keep my bubble healthy. So I will not engage into some political conversations, because if you start engaging, all your home will be about politics. So if you really want to stay focused on some topic, maybe you can create a separate account and have an account about AI, have an account about your personal interest. And also, I really like, and I find it unfortunate that it only exists on mobile. So when you have Chrome Google browser on specifically the mobile Chrome version,
Yes.
when you open it and there is no tabs open, it shows you kind of a news or articles on the topics that it believes will interest you. And again, because Google knows so much about you, what kind of articles you read, what kind of websites you visit, I really find this suggested news in Chrome or in mobile Chrome super helpful. I don't know why Google decided only to keep it for Chrome mobile. You cannot find this feed of news anywhere else. I tried, even there is news, Google News, and Google News has some like a For You tab. And it's not the same algorithm. So I really don't like For You on Google News, but I really like the news, the articles on Chrome on mobile. So this is how I follow news. I don't follow anyone specifically, because I think every person is limited to something. So I want to have kind of keep my eyes open on different things. So yeah, I really trust some algorithms that I find useful.
Well, thank you very much. This was very, very, very helpful for me as well. So really, thank you. As a closing remark, where can our audience follow your work on social media, whatever, on blogs, recent publications? If you can share with us, that would definitely be of interest for the audience.
Yeah, well, most of the time I'm in two places. On LinkedIn, so you can find me by typing my name, Andriy Burkov, in the search, and you will find it. And I'm also often on Twitter and or X. The difference is that on X I just share things that come to mind, and sometimes things that come to mind, they come to mind while I'm working on something. So I work on something and I'm like, oh, wow, this is interesting. And I post it right away on X. So like, if you want to just subscribe to kind of a feed of conscious from me, it's X. On LinkedIn, I try to share something of value most of the time. So some new information of some idea that actually is substantial in my opinion. So, and also I have newsletters also both on LinkedIn and on Substack. So those newsletters are weekly, and I usually share 10 links of what I feel was the most important information that I consumed during the week.
Wonderful. Thank you very much for that. Are there any upcoming projects, things we have to be on our toes to, collaborations, initiatives, things you'd like to share with us before we part?
Well, I have two. Well, I have one large project that is going on this entire year. I'm working on my new book on reinforcement learning, and reinforcement learning has been a big deal since DeepSeek released their R1 model, where they have shown that they used reinforcement learning to radically improve the capability of their model on mathematics, logic, and coding. So I think that by the end of this year, most of companies who offer, training or fine-tuning models will support also reinforcement learning as a way, as a kind of a training mode, because of high potential of reinforcement learning for any domains where you have verifiable results, like in mathematics, in code, and so on. So I've been working on the book, and also this week, maybe early next week, I don't know when this podcast will be out, but I'm preparing also a blog post on how to train a language model to become a business-specific classifier. So I'm entirely from scratch. So you work with on your own taxonomy. You work on labeling the data using language models, and then you fine-tune a language model using this data.
Well, this is something worth waiting for. This is something worth waiting. Do you have kind of an expectation? You said 2 weeks from now?
No, I think either over the weekend or maybe on Monday or on Tuesday, I will be ready.
Well, I can say that with the rest of the community and those who know and those who don't, I'm certainly looking forward for that. Andriy, it has been a fascinating time to sit together with you and mull over some of the topics on AI. I think we could take this blog, this discussion for another 3 hours without sensing that the time has passed. But it certainly has been enjoyable for me very much. So thank you very much for your time and your insights and the information and that you spent with us. Thank you very, very much.
Thank you, Harel. For me, it was also a pleasure to talk to you. So we'll be happy to come back anytime.
Well, you'll certainly be invited. I'm taking a rain check on that. Thank you very much.